I'm sure we all have learned a lot. And may I request you to remember to share your experience with us and tweet at TiE Delhi with hashtag TiEcon Delhi 2022 and hashtag Unstoppable India. Hashtag Unstoppable India. It's raining coins at TiEcon Delhi 2022. You can earn and collect these points as you engage on the event platform today. For the rest of the day, you can redeem these points for a variety of networking and mentorship opportunities. We want to thank AWS for powering this upcoming session. And a big shout out to Kalari Capital, Ivy Cap Ventures, Deloitte, and Dell for their continued support. And now, may I introduce to you the next session and the next speaker. The next session is titled Art of the Possible, Pushing the Envelope of Customer Experiences with AI and ML, powered by AWS. And we have with us Goutam Kurumella, Senior Manager, Startup Solution Architecture, AWS. As a Senior Manager of Solution Architecture team at AWS, Goutam Kurumella works with startups in India in their hyper-growth journey. He specializes in the area of search, data management, and scalable machine learning, and is passionate about solving customers' business problems. Goutam, welcome, and over to you.
Thanks, everyone. Hello, and welcome to this webinar. We are going to discuss on how to push the envelope of customer experiences with A&ML. My name is Goutam Kurumella, and I lead a team of startup solution architects at AWS. So the reach of ML is growing, and this is no surprise. And we have, we have all the analysts such as IDC, for example, talking about the growth or the increase in the spending in the artificial intelligence investments. Their projection is by 2024 that will actually touch 110 billion. Gartner said, by end of 2024, again, 75% of the enterprises will shift from piloting to operationalizing the AI. And very similarly, Deloitte also said that 57% of their survey respondents said that the AI would transform their organization in the next 3 years or so, right? So this means that it is not an experiment. It's not an experimental stage anymore, and it's been pretty prevalent, and people are actually using it for various use cases. However, what we will try to do is today look at some very specific use cases around customer experience and some of the learnings that we had from applying machine learning at Amazon itself. Machine learning is an integral part of Amazon. So we have been applying machine learning in areas such as personalization and supply chain for almost 2 decades. We have also improved the original recommendation, the personalization model significantly over a period of time, and moved it to other products such as Amazon Prime. We also use machine learning throughout our fulfillment process, including the development of a forecast system that can predict the approximate or the appropriate amount of demand for each product we sell worldwide, and to deliver on customer expectation for convenience, cost, as well as the delivery speed. We have developed natural language processing technology to give customers an entirely new way to interact with the technology through technologies such as through devices like Alexa. We have also developed groundbreaking technologies such as autonomous flight through Prime Air drones, and robotics in our fulfillment center to get the packages to customers faster. So almost every department at Amazon today has been touched by machine learning. At AWS, we are innovating on behalf of our customers and to deliver the broadest and deepest set of machine learning capabilities for builders of all levels of expertise. Whether you're an experienced data scientist or you're a business analyst or a researcher, there is something that we have actually built to kind of simplify or ease your job and speed up your research process and drive towards the right outcome. What we're going to do today and what we're going to cover is on 5 broad areas. We'll not touch upon the wide set of capabilities that I spoke earlier, but we will focus, the fundamental capabilities that will actually drive or get you the maximum benefits. And sometimes doing simple things will yield maximum results. So today we are going to talk about forecasting. Forecasting pretty much touches our live daily basis. It is what ensures grocery shelves are stocked, packages are delivered on time, and wait times for your favorite restaurants or delivery are short. Customers are again increasingly demanding more variety, and they want it immediately and they want it cheaply, right? Which means that the supply chains are getting more and more complex, and you can drive efficiency in these complex supply chains only when you are able to, you know, forecast the demand more accurately. And there are a lot of studies by some of the leading consulting firms, and they projected that 20% accuracy improvement would actually result in, say, 5% inventory reduction, or 2 to 3% increase in the revenue. So there is a huge, I would say, business benefit that you will actually derive from accurate forecasting. And forecasting is the science of prediction, right? It's the science of predicting the future. And by examining the historical trends, you can actually make a call on what might happen and when it might happen. And that you can build into your future plans, and you can develop your uh, supply chains, right? So forecasting seeks to minimize two things, right? We don't want to under forecast. When you do an under forecast, which means that you're missing out an opportunity. If you overcast, or if you over forecast, then there could be result. It could result in wasted resources. So it's super important for us to ensure that we reduce the we reduce the errors in the forecasting and improve on the overall accuracy. And today, companies are trying everything from simple spreadsheets to complex financial planning software to generate these forecasts, right? But high accuracy is something which kind of remains elusive. And if you look at the beginnings that we had and the evolution of forecasting that we had in Amazon in the last 20 years, we first began with the very traditional statistical methods, which work very well for the basic data sets and capturing simple trends and patterns. But we sort of ran into limitation as our supply chains become more and more complex and product assortment became more varied. Second phase is when around mid 2000s we began investing in machine learning technologies to operationalize the forecasting at much larger scale. And this approach allowed us to manage scenarios where customers' demand patterns varied by region and product. Uh, Around 2015, we began investing in deep learning approaches to tackle some of the hardest problems in the industry. And we were able to sort of manage some very interesting problems around how you can forecast for new products, how you can manage or leverage the external signals such as external events, and be able to leverage that for better and more accurate forecasting. And with all these learnings of ours, what we've actually done is we built and launched a fully managed machine learning service based on the same technology that we use at Amazon.com. Amazon Forecast puts again the power of Amazon's extensive forecasting experience to the hands of all the developers, and without requiring machine learning expertise. Right, you don't have to be an machine learning expert to actually use Amazon Forecast today. And the way it has been thought through is, you have to sort of provide the inputs. The inputs will be from three dimensions. One is on the historical data, the relevant data, and the item metadata. And essentially what a forecast does is it builds an automate, or it sets up a data pipeline that ingests all this data, trains a model based on the data, provides the accuracy metrics, as well as generates the forecast. Uh, Behind the scenes, it identifies features, applies the most appropriate algorithms for your data, and automatically tunes the hyperparameters as well. And the forecast will actually host your models so that you can easily query them, when required, and integrate with your other planning applications. So this is how it looks from if you go to the AWS console, this is how the forecast would actually look at. There are three steps, right? One or the three stages. The step one is the validation and importing of the data sets. And if you look at the first one, which is the target time series, that's the only mandatory data set that you need to have. And this is essentially the historical demand, right? The primary variable is what you're forecasting for. In this case, in this example that you're seeing on the screen, is the target value. You should have the timestamp as well. That's an important parameter. You should have the item ID, and you can also add the geolocation if you want to forecast certain demand by, say, certain stores. You can actually include the geolocation of those stores, and then you can build the entire forecast. The item metadata is something that you can use it for your categorical variables. For example, if you want to identify what type of category, what is the color of the product, for example, if it is a phone, whether is it a smartphone, right? Yes, or if it is a TV, is it a 4K TV or it's a regular HD, right? So these are the types of categories that you can build depending on the product that you're actually trying to build the forecast for. And you can also incorporate the related time series, and the related time series can include multiple things, such as price for that matter, or the promotional information if you have access to. So all of this can be provided as an input to the forecast system. And the next step is to actually train the forecasting model. What Amazon Forecast does is it actually leverages, uh, you know, multiple approaches. The first and the most easiest option is to use AutoML. Uh, Auto machine learning or AutoML finds the most accurate model among different algorithms that forecast supports today. And we recommend selecting AutoML as different models perform better with different types of datasets. I mean, you can have for example, the best algorithm used for sparse data sets would be different for items where demand is more consistent. Uh, and AutoML optimizes for accuracy and not the training time. So AutoML may take longer to optimize your model, but it will give you the best results. And for more advanced users who understand the algorithms powering Amazon Forecast, you can actually opt to manually select an algorithm for training. You can actually use algorithms such as CNN QR or Deep AR Plus. So some of these things you can actually pick, and you can manually tune the hyperparameters and generate the forecast. And the third step is to build the or generate the forecast itself, and you can decide at what quantiles that you want to generate the forecast, and integrate that into your planning applications, right? So this is how we have simplified the entire process of forecasting, which was traditionally seen as a very complex and cumbersome activity. Again, there are customers globally, and even in our neighborhood, we have customers who are actually using technologies like Amazon Forecast, and this is something which is widely adopted by multiple industries across the globe. The next important topic I want to talk about is around personalization, and personalization is something which is at pretty much all the touch points. If you log into if you use your OTT app, you look at categories. These are personalized for you. The artwork is actually personalized for you. The promotions that you see today are actually personalized for you today, or the order of content or the order of rails, for example, right? So everything is sort of personalized. And in fact, personalization is no longer an optional component of a brand strategy. So, and customers now expect personalized experiences when engaging with businesses. And one of the market research tells us that 63% of the consumers see personalization as a standard level of service. So this has become like a minimum expectation for many of the customers that we serve in the market. And our internal journey on personalization evolved over a period of 20 plus years, right? From the humble beginnings back in 1998, of the customers who bought these items also bought. We started investing in ML personalization decades ago because we realized that our business would scale, rule-based approaches would not be able to keep up with these things. And with that in mind, over the past 2 decades, we have invested heavily in research and development of ML for personalization at Amazon. And fast forward today, we are leveraging this expertise to deliver personalized experiences to users across several different channels and mediums, be it in terms of online shopping, video and music streaming, ebooks, marketing content, and much more. And we do this using the latest techniques in machine learning, developed and perfected over the years at Amazon. If you look at a high level, the gist of Amazon Personalize, it's essentially built based on our learnings. We launched Amazon Personalize, a service that enables you to quickly build a state-of-the-art personalization system, and saving you significant amount of time and resources to develop a similar mechanism. And with Personalize today, you can create highly relevant recommendations for your users, which you can adapt quickly to the changing user content. And access to recommendations is through simple set of APIs that you can always integrate into the existing applications that you're actually building. Uh, I will talk about this in a bit more depth. And behind the scenes, this is important to understand. For example, there are four key stages. The first one is in terms of how you bring in the data. First, you add your data to the personalized either by uploading the data through an API or pointing personalized to data in, say, Amazon S3 bucket in your account. And this data generally includes the user item interaction histories such as views, signups, and purchases. You can optionally include metadata you have about your items, such as genre and category, and metadata about your users, such as age and location. Next, you create a solution using the recipe that matches your use case. These recipes include such as user level recommendations or item similarities and personalized ranking. When you create a solution, personalized trains and optimizes a recommendation model behind the scenes. And these are some of the techniques that actually it uses behind the scenes. The third stage is actually about tuning phase, or we fine tune the recommendations based on the business context. We'll try to sort of go over some of these important capabilities in a while. And finally, you access the recommendations through the real-time APIs, and that you can easily integrate with your applications. If you're building an e-commerce applications, you can integrate into that. If you're building a media application, again, you can easily integrate that using various APIs. You can download the recommendations in bulk. There is a feature for batch processing tasks as well, or you can access those things on the fly for real-time recommendations as well. Uh, if you look at the real-time recommendations, one of the key thing that Personalize addresses is how we can manage the user intents. And uh, we know that users' intent can change quickly. What they're browsing yesterday may not be what they are interested today. And Personalized generates a real-time recommendations that respond quickly to these changing intents, which means that this recommendation updates and adaptation in real time has to happen based or within the user activity and within the user session itself. Just to give you a context, if I was shopping a pair of shoes last week when the model was trained, but now I am shopping for a shirt, Personalized will shift recommendations to shirts and related products that match my tastes. Right. So these are some of the real world challenges we try to solve in Personalize. When we look at the next is actually on the contextual recommendations, we recognize that you have to consider the entire user experience across devices and channels to provide a great personalization. It could be based on the device that you use, maybe what you watch as content on a large or TV. Maybe you watch something else on your mobile phone using the same application. Again, the location parameter is something that might also come in. Time of the day might have a factor. Maybe I'll start my day watching news content, but maybe I'll end my day watching something which is more, entertaining for that matter, right? So, uh, Personalize can generate the recommendations with the given context, and you can choose what context to consider when generating these recommendations, such as device type or location or time of the day. Right, so these are some of the interesting problems that you can actually solve today using Personalize. Uh, and assume that you have built a recommender system, and it has actually giving you all the right recommendations, but only if to find out that those products are not available anymore. Maybe on e-commerce side, the products that are recommended for you, maybe they are not in stock anymore. Or let's say on when you're watching some media content, maybe it's the same movies that are coming as recommendations and you have already watched those things, right? So what's needed is some sort of an editorial control over recommendations to serve exactly the type of personalized experience that your users want. And this is actually a interesting problem to solve. And these are some of the things that you can augment at the time of generating the personalization itself. You don't want to filter it once you generate the recommendations, but you want to incorporate all these business truths at the time of generating the recommendations itself. Uh, the other important problem that we're trying to solve is on, or we have solved, is on how to address the new items in the fast changing catalogs. This is one of the more challenging problems to build the right or relevant recommendations. Uh, and In the industry, again, this is called as the cold start problem. Most recommendation systems rely on users' history of interactions with the items in the catalog to inform the relevance. This means that when an item is new and has few interactions, it is difficult to identify who might be interested in those things. And this can actually lead to a situation where popular items continue to be popular because they are recommended more and new items struggle to break out. And this can be particularly challenging if you have a fast changing content catalog where items are frequently new. So to solve this, again, Personalize enables you to specify an item exploration weight. We introduce this weight to automatically strike the right balance between exposing new content to the user and offering the most relevant recommendations based on their interaction history. And Personalize achieves this using a technique commonly known as explore and exploit, which exposes new items to users in a more controlled fashion and then automatically reduces or increases the exposure based on how users respond to those recommendations. Uh, let's move on to another important capability that we recently released, and this is similar. And similar item recommendations are an important, feature. And the similarity algorithms have been there for a while, and commonly used collaborative filtering mechanisms use item-to-item similarity, but they rely on co-interactions between users and items to identify those similarities. For example, if a lot of users are watching TV shows like show A and show B, these TV shows get identified as similar items. But what about new movies that were added to the catalog, and hence not enough users have actually watched them yet? So they will still be missed by those traditional similarity algorithms, right? So what we actually have done is we added a new item-to-item similarity recipe, which in addition to co-interactions also uses structured and unstructured metadata about items to determine how similar they are to each other. And as a result, what we were able to do is to find items that are thematically similar to each other, even when they do not have any co-interactions, for that matter, right? So these are some of the interesting and challenging problems that we are trying to solve for our customers. And this is again an interesting feature. We announced something called as domain datasets group, or simply called as domain recommenders. As we work with our customers, we found that different touch points in the user journey require different types of recommenders purpose built for the use case. And for media and entertainment customers or for use cases, these are some of the common features of functionality that we have observed. Top picks for you because you watched X, or more like you, most popular. These are some of the common use cases, and we have ensured that you don't have to rebuild or invest additional time to kind of build these kind of features and functionality. The other domain recommenders that we have built is for retail, and in retail, these are some of the popular things, right? Recommendations for you or recommended for you. Customers who viewed this also viewed this. Frequently bought together, most viewed items, or best sellers. All these are today, managed by the domain recommenders, and you can just access it from the API straight away. The third thing that I just wanted to touch upon is on the speech technologies. We started with forecasting. Started forecasting on where the demand is. You kind of created your inventory, or you planned your inventory well. We talked about personalization. So personalization, we are actually showing those products or the inventory that you have, with your customers, and probably the transactions will happen. And you can actually use speech technologies for multiple things, right? You can use speech to transact, or to even serve the customer. You can ask, okay, where are my orders? And in the natural language, you can just speak into it, and you'll get the status of what is the status of your order today. And the journey started with Amazon Poly, and it's a service that turns text into lifelike speech, allowing you to create applications that talk. And it's a text-to-speech service, and we internally use deep learning technologies to synthesize the speech that sounds like human voice. And why we built Poly in the first place. So, the apps use voice to communication with end users are becoming more common every day. And integration is something which is required. There are tons of use cases that in which you can use speech as a mechanism to interact, and neural and both concatenative voices to suit multiple use cases, and you need to sort of balance the cost and volume. Uh, and these are some of the features. One is text to speech. The second one is support for speech synthesis markup language. I'll talk about SSML, the significance of that, speech marks, and then brand voice. If you look at the standard versus neural TTS, for example, in standard voices, we had phonetic transcription of a sentence, and we sort of derive or split the words into subwords, and then we sort of concatenate everything, uh, which means that there are certain challenges, right? So, uh, so, because the sound snippets are stitched to create the words, sometimes there are moments where you hear the robotic voice transitions within a word or across the words. And with neural uh, techniques, it's there are no more of these imperfect voice transitions, uh, and therefore neural voices are, I would say, they sound more lifelike, uh, and that's something which we have been seeing from an adoption standpoint. If you look at Poly again, there are different speaking styles. You can have a conversational style, or you can bring in newscaster style. For example, the way news is read, right? So there's a different way to convey the same message. But when you're in a conversation, the way you talk actually sounds very different. So Amazon Poly today can handle different speaking styles, and depending on the context. Uh, Speech synthesis markup language is an important addition in Poly, and With SSML, you can control the rate of speech. You can speed up the entire, or you can pace up the reading speed. You can, change the language for some specific words. You can improve the pronunciation by providing parts of speech, and you can also select the speaking style. For example, if you want a newscaster type or a conversational style, you can actually embed that as a tag in the speech synthesis markup language. The other important development is actually on the speech marks, and there's no way I can do a demo today, but essentially the techniques such as lip syncing, if you have built an avatar, say using any of the 3D engines, and if you want to synchronize the audio, you can actually use speech marks from Poly, and you can do a lip sync uh, uh, with the avatar or the model that you have built using your 3D engine. Uh, so now we have seen three things, right? Now we have talked about forecasting, we talked about how you display or recommend your products, how you interact, with your customers using speech. And let's assume, the customer has placed an order. It has to be sort of delivered. The last mile delivery has to happen, right? And there are certain common techniques that have been there for a while, and this is not a new problem, right? Vehicle routing problems have been there for the first mention of the truck dispatching problem was almost like 63 years ago, I think in 1959, in one of the research papers. But the problem and the complexity grows, and there is a lot of new ways to kind of solve different problems in the VRP space. And the business models are also evolving accordingly, right? Earlier, if you look at the supply chains, especially the last mile delivery, there is planned delivery and then there is on-demand delivery. In planned delivery, for example, we have e-commerce company, we have online grocery ordering and all of that, right? You have the you have pretty much full information about the entire life cycle. But if you look at on-demand delivery, which is fast evolving today, especially with quick commerce that we are seeing, hyper-local deliveries, this is actually constrained by partial information. You actually do not know from where the orders will come, uh, and where your runner is at a given point of time and things like that, right? So managing on-demand delivery problems requires a different type of mechanism. And there are multiple variants, and most of these have been around for a while and have been solved using different techniques. There are CVRP problems, which are capacitated vehicle routing problems. There are routing problems with the time window. For example, maybe if you're ordering milk, you want that to be delivered between, say, morning 5 and 7 a.m. maybe, right? So the time window becomes extremely important. Uh, and there could be a combination of capacitated vehicle routing along with time windows, which means that how much your truck or the vehicle can carry, and the slot within which it has to be served. Uh, what we have actually seeing is the usage of reinforcement learning techniques, especially for the dynamic capacitated vehicle routing problems. And reinforcement learning generally focuses on reward and penalty system, and you can create an agent which is aware of multiple information such as like driver position, how much capacity he has left, what is the order location, order status, and all of that. With this kind of an information, you can model a reinforcement learning agent that can learn and in a simulated environment, and you can actually use that learned model or the RL model for planning the routes for delivery. And again, there are multiple ways of solving it. One is to use the traditional techniques like OR tools or the operational research tools that have been there for a while. And what we are actually doing is we are helping customers scale those OR tools. Even if they're using any of those techniques, we are helping them scale to do millions of simulations, or millions of calculations in a short period of time. If you look at reinforcement learning, again, we have introduced unique capabilities in SageMaker reinforcement learning. And we have also sort of identified very specific vehicle routing problems that you can handle within this environment. The third one probably will not discuss today, but maybe for future reference, is around quantum computing. You can convert a vehicle routing problem, and this is becoming, uh, uh, you know, this is fast evolving as we speak, and you'll hear a lot about quantum techniques to solve the VRP in the future, in the near future. So keep an eye on that, and we'll be happy to share the work that we are doing in this space as well. And the final thing is around the semantic search. And we looked at how to forecast, we looked at how to recommend, we looked at how to leverage speech to manage the orders. We looked at how to deliver that in a more efficiently. And then finally is how we can actually serve the customers well, right? And one of the unique thing of semantic search is how we can focus on the actual problem and not and reduce the clutter, right? So uh, one of the simple things that we are actually trying to do is, if you the biggest difference between a traditional search and a intelligent search or a semantic search is, in traditional search, we use look for a keyword, and then we look for those keywords in various documents, and we show the list of documents. Whereas when we talk about intelligent search, which internally uses semantic search models, is we are giving the exact answers, right? If somebody asks, okay, where is the IT support desk? We don't just give the list of 10 documents which has information about that particular thing, but rather throw the exact answer, right? It's in the first floor. And say for the customer, how it translates to customer experiences, right? So there could be anything the customer wants to understand about product information, for example, or about a warranty. You don't have to just show them the full document, ask them to read the entire thing, right? If someone wants to know what is the warranty on this product, just tell them, yes, it is 2 years or 3 years, kind of a thing, right? So that changes the whole behavior and the experience that you actually drive with the customers. So uh, you know again, the data is something that you can ingest from different sources, the traditional data stores. It could be in various other applications. It could be in your CRM like Salesforce. It could be in ServiceNow. It could be in SharePoint portal, some of the documents that you might have thrown into that. We can aggregate all of those manuals and documents, and ingest that into the intelligent search application, and you can build this entire thing in a very short span of time. And this is actually a full-fledged managed service, that is ready to use, and you can embed search into various applications that you're actually building into your products and services. So again, broad use cases, you can boost the contact center efficiency, you can enhance your customer search experience, and of course, you can internally improve the employee experience. Um, with these ideas, I would just leave some of the thoughts with you. If you want to know more details, talk to us, contact your AWS account team to get help with your specific situation. Again, tons of resources on aws.amazon.com, and look for machine learning section, and you will find most of the information that I spoke today. So, start thinking backwards in terms of what your customers want, how you can actually solve problems for them, and then try to kind of find the capabilities that will actually fit those things, right? So don't start with the technology, but start with something that you want to solve for your customers. Work backwards and see what will actually make sense for you to do for your customers. Right. So with those thoughts, I want to end the session today. Thank you very much, and look forward to talk to you soon. Bye bye.